So next up, we will be having Dr. Brian Anderson, Director of the National Energy Technology Laboratory, give a keynote about some of the exciting things happening at NETL related to industrial decarbonization. But first, at this time, it is my pleasure to introduce President Farnam Jahanian, a nationally recognized computer scientist, entrepreneur, public servant, and higher education leader. Dr. Jahanian has had a huge impact here at Carnegie Mellon and is one of the Scott Institute's strongest supporters. So please join me in welcoming Dr. Jahanian to the stage.
First of all, Daniel, thank you very much for your kind introduction and also for your leadership as the Executive Director of the Scott Institute. I want to thank the team at the Scott Institute and also all the folks from Carnegie Mellon who organized another successful Energy Week. Thank you again for all the work that you do. Good morning, everyone. I'm going to be brief. It is an exciting day. It's the second day, of course, of this exciting week of discussion and action that's focused on decarbonizing our energy economy and the role of multidimensional, multidisciplinary research policy and collaboration in informing our energy transition. Once again, CMU's Scott Institute for Energy Innovation has put together an extensive slate of events featuring thought leaders from across the country and the world. And of course, this morning's panel that we just saw is a prime example of what Energy Week represents. Leaders from Shell, US Steel, Duquesne Light, Electra came together with our faculty leaders, including Valerie, to engage in a meaningful dialogue on the role of industry in decarbonization. As some of the leaders discussed this morning, over the coming decades, the world must make fundamental transformation in how energy is produced and used, I should say, as the United States is poised to lead in this energy transition. In fact, we're living in once-in-a-generation moment where an influx of federal funding for science, technology, innovation, and workforce development, with bipartisan support, as Brian and I were discussing this morning, will enable these transformations, especially as our nation is returning to an energy leadership position worldwide and to a commitment to international collaboration on clean energy. The U.S. is doubling down on world-class R&D expertise, expanding our manufacturing capacity, and training a skilled workforce to capture the economic opportunities that are created by decarbonization and energy transition. As you see this week, our academic institutions and research labs are playing an increasingly important role in this endeavor. At CMU, in fact, research and energy is colliding increasingly with AI, with robotics, with advanced manufacturing, and other advanced technologies. The resulting innovation holds the power to make our homes, offices, industry, smarter grids, all of them more efficient, and to make our energy cleaner and more sustainable. But the work of academic and research institutions might extend, of course, beyond campus to our broader region. As all of you know, CMU, University of Pittsburgh, West Virginia University, and the National Energy Technology Lab are all working with industry partners and incubating new ideas and technologies. Through these collaborations, we're hoping that we are going to have a much more efficient energy future and reducing pollution, improving processes in industries, shaping national policies, creating opportunities for more people to work and thrive, especially in regions of the country, including our region, where it's most needed. In fact, given the widening opportunity gap that we're seeing across society, we have a moral obligation to ensure that our innovation benefits all citizens, leading to a better quality of life, more jobs, especially historically for those who have been left behind. Our keynote speaker, in fact, today is helping to meet the urgency of the moment and working collaboratively, demonstrating that building effective energy solutions can indeed create a more sustainable future that benefits everyone. It's my great pleasure to introduce Dr. Brian Anderson, who is the director of the National Energy Technology Laboratory at the Department of Energy. In his capacity, Dr. Anderson manages the complete NETL complex, including delivery and execution of the laboratory's mission, which is to drive innovation and deliver solutions for an environmentally sustainable and prosperous energy future. Dr. Anderson is an alum of West Virginia University and holds a PhD from MIT. Yes, MIT people are welcome on our campus, absolutely. We have many of them on our faculty. He began his career on the faculty of the Department of Chemical and Biomedical Engineering at West Virginia University. As you know, we have extensive collaboration with WVU. In 2006, he joined that university and stayed at West Virginia University until 2018 when he joined NETL. For his work in natural gas hydrates and carbon dioxide sequestration, he received the 2012 Presidential Early Career Award for Science and Engineering, and he received also the Department of Energy Secretary Honor Award for his work with DOE in response to the BP Deepwater Horizon oil spill. In 2014, Brian founded and built the West Virginia University Energy Institute, which is the largest energy collaborative research organization at the university and focused on advancing technology through research development and demonstration within the energy industry. As I mentioned, he joined NETL in 2018, and in 2021, Brian was named as the executive director of the Biden administration's Interagency Working Group on Coal and Power Plant Communities and Economic Revitalization. In this role, he advises the Secretary of Energy and the President's Climate Advisor on the future of America's coal communities. There is a lot more to tell you about this, but we actually want to hear from Brian. Brian has a long history of working with federal departments and with academic institutions to advance energy technologies, and a long-term resident of West Virginia and a descendant of coal miners. Brian brings deep expertise in regional innovation and technology development for the energy sector. It is my pleasure to welcome him back to our campus. Please extend a warm welcome to Brian Anderson. Brian.
President Jehanian, thank you so much for that way too warm welcome, and I really appreciate the organizers of CMU Energy Week. I always look forward to the middle of March or the late part of March for this event at Carnegie Mellon University. And I have to say, this year, the topic of industrial decarbonization was extremely exciting to me because, as I'll talk here a little bit more about, it is often the overlooked part of our very challenging effort to decarbonize our entire economy by 2050. And I appreciate not only the partnership historically that I have had with Carnegie Mellon University when I was at WVU, but also the partnership with the National Energy Technology Laboratory. As most of you, and boy, I hope you know, if not, I haven't been doing my job, but NETL has its roots embedded in our partnership with Carnegie Mellon University. We are the oldest national laboratory, and that we were founded in 1910 after a spate of mine explosions in 1908 to solve that problem. And for the last 113 years, that's been our mantra, is to try to solve the most pressing problems in energy production in the world. And so for the last 35 years, we've been working on carbon capture technologies, understanding that we have a long ramp in order to develop those technologies because we are going to need to mitigate carbon in our future. And so when I think about the future of the energy sector, I think of not only the challenges that we exist from a technical standpoint, but everything that the panel that preceded me discussed is on the table. It's the markets will be a big challenge for us to understand how we can create the market mechanisms in our free market economy that drive not only decarbonization more broadly, but also when we think of the market mechanisms to ensure reliability and resiliency, those are constraints to our energy system, as well as affordability, and we drive forward. And before I jump into a set of slides, yes, I used to be a professor, so the danger is I'll get into a bunch of slides. I want to reflect on a moment in time under the previous panel that I think was just really prescient. When we think, Brian from Duquesne Light and Power pointed to the inflation, and pointed to the Infrastructure and Jobs Act, the IIJ, or otherwise known as the Bipartisan Infrastructure Law, as one of the biggest efforts of the federal government since the New Deal, the biggest legislation since the New Deal. That is absolutely a point I want to drive home in my talk. Brenda from US Steel talked about the complexities of the carbon markets and the lack thereof to drive decarbonization of products like steel and plastics. And everything we're talking about, industrial decarbonization, we need those market mechanisms to create the pull for companies to start decarbonizing. Sarah from Shell mentioned that we do have a legislation for decarbonization like 45Q that can help drive that create a type of market specifically for capturing carbon and storing it. However, as Gregorius mentioned, we need to make sure it's safely stored in the Storage Act. And Sandeep very eloquently discussed how we need to make sure that all of the market mechanisms that are put together are technology agnostic, because we have an end goal together. But then I want to layer on another complexity in that. Going back to the technologies, we're at the stage we need to commercialize and move those technologies to market and overcome barriers that are upon the commercialization that require the first-of-a-kind investments that are unique to each of the technologies, so we can see all the above energy strategy. This is a big deal. It's a lot of complexities when it comes to getting this story right, and it only takes partnerships. I mean, it can only be achieved through the types of partnerships across academia, with academia and the federal government, academia and national laboratories, and across the 17 national laboratories that we have in the Department of Energy. So with that, I will actually talk now about industrial decarbonization a little bit. And the one last piece that I will add, to this, and Valerie, I didn't mean to leave you out of this discussion from the last panel, is how we can do right by communities in this energy transition. And that is something very near and dear to my heart as a grandson of a coal miner and a lifetime West Virginian. So when we think about our integrated carbon management solutions and other types of solutions to achieve industrial decarbonization, setting the stage is that the President Biden has announced pretty lofty, aggressive, and challenging goals for decarbonizing our economy. We need to decarbonize our grid by 2035. My math, right? That's 12 years. That's a big challenge. We have a long way to go and a lot to change on the grid itself. But then how do we get to a decarbonized economy by 2050 creates another set of challenges. And so I always want to benchmark the fact that we spend a lot of time in our society when we talk about decarbonization about talking about the grid, how we're going to decarbonize the grid. Well, it's only a quarter of our emissions, so let's not forget about the other 3 quarters. Transportation, we are on a bit of a pathway, looking through electrification of at least the light-duty vehicle fleet, but there are some tremendous challenges to the rest of our transportation sector. Particularly, we could spend hours talking about sustainable aviation fuels, talking about how we can decarbonize our freight system. And I know CMU is working very hard with some industrial partners on some of those aspects as well. Then there's the other quarter of the commercial and residential sector. We have a lot of gas stoves in our society. We have a lot of furnaces in the residential sector providing heat to homes. We have, again, a very long way to go to decarbonize that sector. But the industrial sector, and this is what I want to give a huge applause to Carnegie Mellon University and the Scott Energy Institute for bringing the industrial decarbonization topic to this year's CMU Energy Week, because this is going to be a huge challenge. Everything that the previous panel laid out, all the market mechanisms and the technologies that need to come to meet the challenge, rise to this challenge of industrial decarbonization, have to be all put together. And so we have a long road to hoe. So when we think about the context, I've mentioned collaboration. If anybody's not familiar with NETL, we are one of 17 Department of Energy national laboratories. The 17 DOE national laboratories represents about 100,000 researchers around the country. We are really the crown jewel of the Department of Energy. And NETL, we are the unique one. We are the one that is government-owned, government-operated, which means we have an opportunity to assist with the pathway that the federal government is going and in a way that many of the other laboratories can't. And so to that end, we not only are historically the Office of Fossil Energy and Carbon Management's laboratory, but we support no fewer than 9 different program offices across the DOE, helping to orchestrate the implementation of everything from the annual appropriations to the Bipartisan Infrastructure Law to the Inflation Reduction Act. And I could spend the next hour talking about all the ways that we're assisting with that implementation. But of course, our largest facility is here in Pittsburgh, it's in Allegheny County. It's not too far from Pittsburgh in South Park. And at this facility, we have been there again since 1910. Our other 2, one is in Albany, Oregon, and another in Morgantown, West Virginia. And on an annual basis, we help the department manage about $1 billion a year of federal funding. Because of the Bipartisan Infrastructure Law, last year we did about $15 billion worth of federal funding with our industrial partners. We have a number of core competencies as a national laboratory in everything from computational science and engineering and material science and engineering, geologic systems, energy conversion engineering, and energy systems and analysis in each and every one of these partnering with faculty members at Carnegie Mellon University. And we wouldn't be where we are as a national lab without that partnership in CMU. We also work hand in hand with the department in implementing programs, as I mentioned, across carbon management and resource sustainability in the Office of Fossil Energy and Carbon Management, but these other Department of Energy offices. But specifically, our goal is to help de-risk and demonstrate technologies, not only what happens in the laboratory, but then how we get those technologies out into the market. And specific to industrial decarbonization are ways that we can help develop and implement point source carbon capture and carbon dioxide removal that includes direct air capture, carbon conversion, and carbon transport storage, all topics that were covered in part by the last panel. I do want to give a little plug is that for the first time in NETL's history, in the President's budget request a couple of years ago, we were funded to build a direct air capture test center at our Pittsburgh site, which we've already begun construction on and will start hosting direct air capture technologies next year. This will be a real one-of-a-kind demonstration, development, and test facility for direct air capture technologies. But as was pointed out, direct air capture, pointed out in the last panel, direct air capture is one technology that may come at the end of the very hard to decarbonize technologies and may be the part of the economy that's impossible to decarbonize to have the carbon offsets. And so we need the full portfolio. When we think of industrial decarbonization, globally, this is the IEA projections for historical numbers from 2000, 2010, 2020 of the CO2 emissions in the industrial sector. We can see they've been rising, obviously, but under 2 different scenarios in the purple bars, when we look at a net zero energy scenario, we can see a significant decrease, but yet a lot of industrial CO2 emissions. If it's the announced pledges that have been announced globally, we can see that we're not really going to cut into industrial decarbonization. So once again, we go back to we need the full suite of technologies, policies, markets, and in fact, the purchasing power of the end user to purchase low carbon embodied products. When we look at the United States specifically, and we try to understand where our industrial CO2 is coming from, I hope many of you have seen a Sankey diagram. As a nerdy engineer, I love these. But when we track our industrial emissions, you can certainly see today, or at least in 2021, coming from mostly natural gas and petroleum and the electricity sector. So certainly when we decarbonize the electricity sector and we electrify large parts of our industrial space, we can start to cut into our CO2 emissions through electrification and decarbonization of the grid. However, there's a lot of industrial heat and power that then requires the hydrogen. Hydrogen is potentially a carbon-free energy carrier for combustion products and potentially even ammonia. but it's a big challenge. So now diving a little deeper into the industrial space, understanding the various sectors within the industrial sector. So here on the bottom left, for industry and manufacturing, we're really looking at huge contributions from bulk chemicals, from refining, iron, steel, aluminum, a balance in manufacturing and food production. And so when we start to dive down specifically into these areas, what are our technology options, and then ultimately what is the market? I want to present at least a little bit of the work we're doing at the National Lab, and then expand it into the entire Department of Energy. So some of our facilities that we're specifically investing in at NETL is our Center for Sustainable Fuels and Chemicals, which is designed specifically to try to tackle this industrial decarbonization space, certainly in the fuels and chemical sector, which I showed you was some of the bigger contributions, but certainly how we can then move into cement and steel and iron production. We have, as I've mentioned, we have a decades-long experience in developing carbon capture technologies and commercializing them, which will play an important role. But some of the unique technical offerings, and here's where there's a call for collaboration to those who are in the CMU audience and others, that we need to be bringing together expertise from across many different areas, including in carbon management, in disposition recycling, the low carbon footprint feedstocks that then feed into our supply chains in the industrial manufacturing space, and then process intensification and increased efficiency. So specifically in that area where there's some tremendously unique opportunities for decarbonizing a lot of the chemical industry value chain, include areas for certainly creating alternative feedstocks, but there's a huge emphasis on the role of hydrogen. And so I'm going to spend just a few moments here discussing the Department of Energy and NETL's role in the future hydrogen economy. So many of you, and if not by this point, I hope all of you have heard about the Bipartisan Infrastructure Law, which then now has equipped the Department of Energy with $63 billion more funding to specifically design demonstration and deployment scenarios for a number of technologies. And one that has gotten a lot of attention is in the hydrogen production space. So there's an opportunity for, that's in $8 billion of federal funding to develop hydrogen hubs around the country. This is something that's out on the street. I can't really speak too much about it because the proposals are due on April 7th. But in fact, we are, as the GoGo laboratory, we have ensured that we are on the outside of the department looking in, meaning we're partnering with many of the hydrogen hub proposals that are going forward. But why this is really important to get right, as it was mentioned before in the previous panel, putting together the collaborations of multiple parts of the industry, multiple hydrogen producers, as well as the end users of a carbon-free energy carrier, helps create the opportunity to get over the chicken and egg problem. At least if we can put now a number of hydrogen hubs around the country to demonstrate that we can produce clean hydrogen through multiple different ways, either through production of hydrogen from original fossil feedstocks with carbon capture and storage. You may call it blue hydrogen or turquoise hydrogen if it's a pyrolysis project, through pink hydrogen if it's nuclear, through green hydrogen if your hydrogen is through electrolysis from renewable sources. All of these are on the table because ultimately we decarbonize that energy carrier, and that energy carrier has an opportunity to assist with decarbonization across huge parts of the value chain. Then when we think of opportunities in process intensification, working again in collaboration with academia and with industrial partners like ExxonMobil and Shell, in fact, we can invest in new types of technologies that input themselves into the existing supply chain, the existing commercial deployment of the fuels and petrochemical space. And one of these is how we can start to electrify many of our industrial processes. So one particular example that I get often very excited about is the introduction of microwave technology into chemical reactions. And so if we input energy into a chemical reaction using traditional thermal methods, you're heating up everything, and you move everything up the temperature barrier, and the kinetic energy moves out to all molecules equally, effectively. At least from a statistical mechanics vantage point, at least it distributes itself across molecules. If we can identify reaction pathways that certain transition states or transition states on catalysts can be activated at particular microwave frequencies, we can input energy into that reaction in a much more efficient manner and not heat up everything else. And of course, those of you who are, if you're not familiar with microwaves or the one in your in most people's homes, it is specifically designed for the resonant frequency of liquid water, which is why it does a very good job of heating up water, but not a very good job of melting ice, and because it's a different resonant frequency. So what we're able to do is tune that frequency and tune that power exactly to the reaction, inputting exactly the type of energy we need into a chemical reaction. But the ancillary benefit here is now we're using electricity. It can be green electricity. It can be green electrons. It can be electrons that have been decarbonized through carbon capture and sequestration, or any other method on that green zero carbon grid that we will have by 2035, giving us a tool within our quiver to be able to assist with decarbonization. Other areas, well, and so I had another slide on microwave technologies, but one huge area in which we've seen some tremendous breakthroughs in using microwave-assisted reaction technologies, developing a low energy, low temperature, and low pressure conversion of natural gas into ammonia. This is extremely exciting because we've been using the Haber-Bosch process for nearly a century now, if not over a century. And the Haber-Bosch process is at high temperatures and high pressures and not a very efficient conversion process. And why this is really important is if I were to go back, and actually I will just go ahead and go back to our CO2 emissions by end use. Another huge area, actually not shown on here, but when it comes to decarbonizing our entire economy, agriculture is up there as 1/8 of the pie. And when we think of this agriculture, it is not only the energy expended at the farm itself, but also the energy that goes into our fertilizers. And so when we look at the life cycle CO2 emissions, and I left that out of my little recap of a moment within the previous panel, if we look at the full life cycle assessment, it is really important to decarbonize our fertilizer and ammonia. But also it gives us another tool for assisting with the globe to decarbonize the point source. Within Japan and Mitsubishi Heavy Industries and others are very excited about the potential of using ammonia as a carbon-free energy carrier for stationary power to replace natural gas. That's just a bit of a highlight. And now I want to really try to bring it home. All of the industrial decarbonization and our pathway for our energy transition as we're embarking on decarbonizing our entire economy by 2050 is how these technologies and our pathway can help contribute to ensuring that no one is left behind. Now, I mentioned this is near and dear to my heart, and President Jahanian mentioned that I have been asked to lead an interagency working group on coal and power plant communities and economic revitalization. To give you a sense of what that is, we now have 11 federal agencies, plus the White House, plus the Office of Management and Budget, all working together on a single goal. And that single goal is under the Office of the the Senior Climate Advisor, Ali Zaidi. It was Gina McCarthy at the beginning of the administration, coupled with the Secretary of Energy, Secretary Jennifer Granholm, and now John Podesta, the head of the Office for Clean Energy Innovation and Implementation. We have a group of these 11 federal agencies all designing what the policies, the stakeholder engagement, the investments, and the impacts in communities that can come together through the Bipartisan Infrastructure Law, the CHIPS and Science Act, and the Inflation Reduction Act to ensure that all communities across the country can participate in this clean energy transition, whether it's the power sector, whether it's the transportation sector, and the industrial sector. So 2 years ago, we produced a report to the President identifying 25 priority energy communities across the country that will see the largest change in job growth. I'm glad to see David Foster here. We build a lot off of some of your work. That will see the largest change in employment over the coming decades as we transition our economy. And so what we were trying to do is position those communities for success, to be active participants in the clean energy future. And so, of course, southwestern Pennsylvania is on that list of the 25 priority communities, as well as many communities in Appalachia, the Four Corners region of Arizona, New Mexico, Utah, and Colorado, and certainly Wyoming, being the #1 coal-producing state, will see tremendous changes in their economies at the community level over the next few decades. So what we've been able to do is corral across these 11 federal agencies and all of these transformative, once-in-a-lifetime opportunities for basically this century's New Deal, and corral all of those opportunities for participation in the energy transition. And so we now have $256 billion, and I have to always look at the slide because we update this daily and it changes nearly daily. $256 billion of open or planned competitive funding available for communities, for industrial participants, for state and local governments, and $329 billion of open and planned funding directly to states and communities. And so, yes, these two are additive. We are talking nearly $600 billion that we have at our disposal to help put into communities for everything we've talked about: decarbonizing the grid, decarbonizing the industrial sector, working hand in hand with groups of industry to put together things like hydrogen hubs and carbon dioxide and storage hubs and direct air capture hubs. As well as a provision that you'll find in there with $500 million that just makes me so excited, $500,000 for clean energy demonstrations on abandoned mine lands. And these are opportunities to then bring an entire workforce to participate into that clean energy transition. And so, yes, we are helping actively manage over 140 different opportunities, including plus 22 different IRA tax credits, to ensure that there is an opportunity, again, for everyone to participate in this clean energy transition. To summarize some of the provisions within the Bipartisan Infrastructure Law, you can see we have about $100 billion of infrastructure investments, everything from transportation infrastructure to broadband, abandoned mine land reclamation, orphaned and abandoned oil and gas wells, and southwestern Pennsylvania being the home, being the origin of the U.S. oil and gas industry, has pretty much the most abandoned mine lands. Pennsylvania does have the most abandoned mine lands and the most orphaned and abandoned oil and gas wells. So there's a tremendous opportunity for us to now help clean up the environmental legacy and create opportunities for investment. And then critical minerals and rare earth elements and clean water are some of the big highlights of all of this effort that we're helping to steward. Then we layer on the Inflation Reduction Act and all of the provisions, not only to create the types of incentives for investments in the clean energy sector, but also some of those provisions that are helping to target those investments into energy communities. As you can see, there's $250 billion of loan authority in the Department of Energy's Loan Program Office to invest in redeveloping or repurposing abandoned or mothballed or ceased operations in fossil energy assets. This is a tremendous, yet again, a tremendous opportunity, particularly in light of an ongoing financial crisis in the banking sector with disproportionate effects in the clean energy space. To have a loan program guarantee, a federal government loan program office guarantee on repurposing fossil assets into the next clean energy economy is, again, tremendously exciting. We had a webinar just on Monday this week. Jigar Shah, the director of the Loan Program Office, Christina Costa, the deputy director in the White House's Office of Clean Energy Innovation and Investment, and I, as well as our USDA colleagues, were speaking to this particular opportunity. Then there's also $4 billion in clean energy manufacturing tax credits, the bonus tax credits for clean energy projects, all helping to drive what the future investments of our clean energy economy into targeted communities There's also support for communities, workers, and their families. And then moving forward in this year's President's budget request, which came out last week, you can see that there's a enhanced emphasis on the Department of Energy's new part of the mission of moving out demonstration projects to help de-risk the early stage projects, all toward this transition toward our clean energy future. I want to mention something else that we weren't able to put in the slides because they were just released yesterday. But last week, Secretary Granholm at CERAWeek announced a new series of reports out of the Department of Energy you can find at liftoff.energy.gov, and that is one word, L-I-F-T-O-F-F, liftoff.energy.gov. You can find a series of reports on the pathway to commercialization of clean energy technology. There are 3 reports that are already up there today. It's the advanced nuclear or innovative nuclear energy technologies, a tremendous opportunity for us in the clean energy space. Hydrogen, or the pathway for commercialization of clean hydrogen, and the pathway for long-duration energy storage. The next report that will be coming out is carbon management as well. And so what we're doing in the department is trying to work collectively across the department, across the national labs, academia, input, and the private sector to identify those critical needs for how we move the technologies into commercialization, everything that includes the market mechanisms that are necessary, the de-risking of individual technologies, and areas where we need to demonstrate new technologies at scale. And to give you a sense of the way that this particular program in Liftoff was being looked at by the department is with a particular and specific emphasis on industrial decarbonization. And so again, I go back to my comments at the very beginning of the applause to Carnegie Mellon University and the Scott Energy Institute for thinking about bringing this particular topic to the forefront because it is absolutely on the forefront of our minds and one of the biggest challenges that we see in achieving the 2050 goals of decarbonizing our entire economy. And so with that, I'll close with an emphasis on our efforts at NETL through all 11 of the federal agencies that we have in the interagency working group. And these are agencies like the Department of Transportation, the Health and Human Services, Education, Energy, Labor, the EPA, and the Department of Commerce and Treasury. Keep your eye out. It was already mentioned that the industry is looking for that guidance out of the Inflation Reduction Act and these tax credits. I can promise you today that that guidance is coming out in the coming weeks, not months. And when we think about the speed at which tax credits and guidance toward the industry has historically come out, this is truly unprecedented, that we are at the cusp of being able to release this guidance. It took us years to get 45Q guidance out. 45Q is the tax credit for sequestering carbon dioxide. It took the federal government, it took us years to get that tax credit and guidance out. And the Inflation Reduction Act was just passed last year, and we're about to roll out the specific guidance on all of these manufacturing tax credits and as well as energy community incentives and adders within the Inflation Reduction Act. There is a sense of urgency, there is a sense of intention that there is an opportunity here, not just the challenge, but the opportunity for us as a nation to lead the world, not only in the technology that goes on into our economy to decarbonize our economy, but for us to lead the world by example of showing how we can innovate within a free market economy, the types of incentives that will get us there. And so we need all of your input, and we are absolutely committed to investing in the clean energy, advancing environmental justice, and tackling the climate crisis. So with that, thank you very much, and I hope I've left some time for some questions.
Thank you, Brian, for such a good keynote. Very exciting to hear all the stuff that's happening at NETL around industrial decarbonization. So as we've done in previous Q&A sessions, I want to prioritize students for the first question. So do any students have a question that they would like to break the ice with?
Thank you so much. My name is Maya. I'm a PhD student in chemical engineering. I was actually curious about NETL's stance and also your personal stance on nuclear and increasing the amount of nuclear in this region, especially given Westinghouse's presence. And I know that you had mentioned, electricity is really, really focused on, but it's only 25%. However, there's this big move towards electrification. And in order to decarbonize some of these industrial sectors or transportation sectors, I mean, that slice of the pie is just going to grow. So I was just curious about your stance on nuclear.
Maya, thanks for that great question. And so when it comes to, well, you're absolutely right that the 25% is a snapshot today. As we electrify the transportation sector, we're going to eat into that pie. As we electrify parts of the industrial sector, the need today to modernize our grid is unprecedented, maybe since the Rural Electrification Act. And so that's a really important point to make. When it comes to nuclear, the advances that we've seen in new nuclear technologies, to name a few, the Natrium reactor being developed by TerraPower. They've announced that they're going to build their first unit in Kemmerer, Wyoming, one of our coal communities. We've worked very closely with TerraPower and the community of Kemmerer to see that project be successful. Plus, another couple of technologies. One's X-Energy, which is really focused on how you can take nuclear and convert it into a combined heat and power opportunity as well. And there, sorry to leave out many others, but the advances in nuclear energy has come to the point where now the concerns that we had, very valid concerns around the potential impact beyond the fence line of the plant under a upset scenario, those new advanced nuclear technologies are being designed specifically to reduce that risk outside the fence line, to where the actual area of impact is wholly contained within the fence. Just to give you a specific example, within the Natrium reactor design is a molten salt reactor, where there's enough molten salt to contain the thermal energy to then allow the reaction to ramp down and contain it just in thermal energy within the molten salt. Just to give you a sense of that particular design. So that's not to discount, let me say, for instance, the fact that we just, and I always lose track of time, I think it was maybe like 2 weeks ago, is somewhere in the last 2 to 3 weeks, we achieved criticality of a new nuclear reactor, new fission reactor in the United States for the first time in decades. This is an opportunity at Vogtle. This is an opportunity now that we see to see that resurgence. Now, certainly with new technologies comes new regulation and a new regulatory framework that each of these reactors needs to see come to fruition. And but because the Nuclear Regulatory Commission of the United States is truly the gold standard for the world, when we get this right, we can have a lot of confidence in the ability for nuclear to contribute under great scenarios. Another real advantage, and sorry, you get me off on nuclear because I actually get really excited about it, so I think you can tell what my personal stance is that the new reactor designs have the opportunity to do load following and to do flexible power generation that the reactors of the past did not. And so, in fact, that's some other advantages of the new advanced nuclear technologies is that the power that's put onto the grid does not have to be as steady. There is actually a ramp rate that we can design right into the new advanced nuclear reactors. So I envision that in the coming decades, the TerraPower reactor is looking to come online late this decade. And but we will see I actually think we'll see a huge resurgence of nuclear in the United States.
Thank you, Maya, for that really good question. I think we have time for just one more question.
And I'll try to be less long-winded. Maybe we can get two.
No, it's all good.
Hi, I'm Casey Kelly. I work at ClearPath, we're a DC-based think tank that works on federal policy. And I was hoping to get, I was hoping to get your perspective working at a national lab and within DOE on how the newfound authorities and scope of your work that happened with the Energy Act of 2020, moving beyond basic research and development into demonstration, early stage? What are some of the challenges that you see both internally and also in terms of workforce development and attracting and retaining talent?
These are the questions. You've hit on the question that keeps the 17 lab directors up at night every night. One is recruiting the type of talent that we need in the future the future economy. There is right now a huge pull because there is so much investment in the private sector, in the commercialization space, particularly in clean tech, that there's a really exciting opportunity for the next generation of engineers and scientists to move into that private sector and work for a lot of startups. Across the national lab system, we are seeing this challenge to make sure that we are able to recruit the best and brightest. And when we think about that particular tug between moving into maybe a venture capital space, moving into clean tech startups, if you're in a clean tech startup, you're not working on basic science. I'll tell you, you're trying to build that prototype or move that technology to commercialization. And so right now, it is absolutely paramount that we are able to bring in the next generation of the workforce to make sure that we have the bandwidth to focus on basic science. Because that basic science that we work on today and what we learn about, whether it's the fundamentals of interaction of molecules at our light sources, all the way through discovery science of new materials new materials or new chemicals, to be able to the basic science leads into what the breakthroughs will be that come onto the market in 2030 or in 2050. And so right now, we are seeing a bandwidth issue across the national labs, where I think there's an absolute important, I can't overstate the importance of the contributions of the academic sector here. And so what we are trying to do as a national lab team, and certainly at NETL, is develop better, deeper partnerships with academia so that we can help stave off what could be a gap that is pulled between applied science and basic science. And so anyway, that's we have all the authorities in EPAC 2020. The appropriations cycles have created the tension, particularly with a lot of focus on my boss, Secretary Granholm, will say deploy, deploy, deploy. But that is not at the expense of the basic science that we need to be investing in today and into the future. I hope that answers your question, but it is really an important one.
Hello? Yes. Dr. Anderson, thank you so much for joining us today. It's really an honor to have you here. And thank you for the very good questions. Let's give him a round of applause. Thank you.
Daniel, thank you for having me.